This is going to be an exciting session that we have here this morning, and I'm going to lead it as a panel discussion. If I could have the next slide, we go right into it. And so it's going to be an EV charging panel discussion here. It's an item that is very relevant right now, and we've kind of created a panel of really amazing people that can help guide and inform us on issues related to the implementation of some of our requirements here. Kind of threw up these two slides. The first one kind of actually shows a gas station with gasoline prices and kilowatt hour prices too, and this is right in Denver. And our program is getting with the times too, and we've acquired our first Ford F-150 Lightning, which is a completely electric vehicle. We have it set up with gasoline provers or provers on the back, and we are taking it to, ironically, to gas stations to check gas pumps with an EV charging vehicle. But if I can get the next slide. So we have a really great distinguished panel here, and I will moderate the session, but I just wanted to do a real quick introduction to some of our panelists over out here. Francesca Wall is a Senior Charging Policy Manager, Public Policy and Business Development at Tesla. Francesca manages electric vehicle charging policy in North America as part of policy and business development team at Tesla. She leads regulatory engagement and drives Tesla's North American policy positions and efforts on EV charging to increase broad access to affordable, convenient, and reliable EV charging. Francesca has been with Tesla for over 7 years and has held various roles, including policy positions, advancing the company's solar and storage priorities. Glad to have Francesca with us this morning. Dr. Keith Bradley is a physicist and lawyer. As a scientist, he has developed hydrogen storage technology for fuel cell vehicles, nanoelectric chemical sensors, and nanotube device fabrication processes. As a lawyer, he has been counsel at the Federal Consumer Financial Protection Bureau and at the Department of Energy, where he has advised on energy conservation regulations and nuclear export controls. Today, he focuses on regulatory compliance. He represents Electrify America as the largest open network of fast DC chargers and has been a member of NCWM since 2020. Yusuf Grigorev is Tesco's software engineer, manager, and lead NPD engineer. He has been with Tesco for 5 years, working on Tesco's next generation products. This includes next-gen MQBs, MTBs, 2990s, 6330s, and T4000. I'm sure you'll learn a little more about that maybe today. Yusuf tries to provide the best products by listening to the customers and making the next best thing since sliced bread. Tall order. Jim Willis is director of the New York State Weights and Measures. His past experience in the department includes inspection of LPG delivery meters and training officials in municipalities, and later overseeing the Petroleum Quality Program. He became Assistant Director of Weights and Measures in 2019, followed by his appointment in 2022 as the Director. Kevin Schnepp is Environmental Program Manager for the California Department of Food and Ag of Measurement Standards. Kevin manages the Metrology Lab, 2 fuel lubricants and automotive products labs, and the Hydrogen and Alternative Fuels Lab. His duties also encompass the division's work in ZEV infrastructure standards and specifications development, along with facilitating policies and regulations for the oversight of zero emission and lower carbon alternative and renewable fuels. Mark Paquette is Weights and Measures Section Chief and Metrologist at the Vermont Agency of Agriculture, Food and Markets. He began his career as an inspector for the Consumer Protection Section. He served as lead inspector for weights and measures devices, including large capacity scales and vehicle tank meters. In 2010, he attended the NIST Basic Metrology Training for Mass Volume and Length and became the Agency of Agriculture and Weights and Measures Specialist Metrologist, establishing 2 new metrology labs in an 8-year period. Paquette currently serves as Western Weights and Measures Section Chief and Metrologist. And our final panelist, Tina Butcher with the NIST Office in Weights and Measures, needs no introduction. I think every one of y'all has worked very closely with NIST, and we're glad to have Tina here representing NIST and just representing NIST. Next slide, please. So just kind of, I had a few slides I want to go through just to kind of set the backdrop and stage for the session. And we want to keep it really casual. I'll have a few questions for our panelists just to lead things off and then really open it up to questions that you could direct to each of them. Hopefully it can be a very interactive session and get many of your questions answered here. So the reason this is topical, obviously, is the Electric Vehicle Fueling Systems Code in Handbook 44 changed from a tentative, the tentative status of that code was removed so that it took effect January 1 of this year. We're just into 10 days into January. And so I think it would be really timely for us to be looking at this. Next slide, please. One of the reasons the code was changed from tentatives to, or the tentative status was removed, obviously was, the code has been developed quite a bit. It's not perfect, just like any other code, but one of the drivers as a backdrop was NEVI, the National Electric Vehicle Infrastructure Program that's administered through the Federal Highway Administration. And I believe most of you all are familiar with this infrastructure program that's actually going to be infusing $5 billion into electric vehicle infrastructure across the country. That money will be coming to your state Department of Transportations, and they will be rolling that money out either through energy offices or other sorts of offices in each of your states, providing grants and funding for infrastructure development. And so it's a huge influx of money that will really help with increasing the network of chargers that are available there. Next slide. So right now, there's been an increase in the number of EV chargers on the road in the US. So as of the last quarter of 2022, or the third quarter of 2022, there were 1.7 million electric vehicles. When you compare that to what it was just 4 years ago in 2018, it's a huge increase. It was just 400,000 and it's gone to 1.7 million. To put that in perspective, 1.7 million seems like a big number, but there are 290 or close to 300 million registered vehicles in the US. So it's a fraction of that overall percentage of vehicles, but when you look at it on a closer scale, there's been a significant increase, and I believe that was pre-NEVI funding. I think with NEVI, it's going to ramp up a little more. Another interesting statistic that I saw was we're kind of now close to around 6% of auto sales, new auto sales in the US. So it's kind of starting to get a little bit of, a little more of the market share, and it was up almost 3 times up from what it was just 2 years ago. So there's an increase as the infrastructure is out there, the cars, and then they kind of follow each other. Next slide, please. Also, kind of more close to home for us, the network of charging stations has grown. So now there are close to 50,000 charging stations across the country, and with about 128, 130,000 actual charging ports. I should just preface this with not all of these are commercial chargers. There's many of these that are free, so, and not retail. Not all of them are retail charges that where there's a transaction fee out there. But again, just wanted to put some information up on the number that's out there. Next slide, please. This one, again, is a very simple slide that I want to kind of share. And I think most of you all already know this. There's 3 types of chargers out there. The level 1, which is really kind of the lowest voltage, 120. I used to have a few EVs myself over the years, and that's all I use. You plug it into the outlet at home and charge it overnight, and it would charge a car with a smaller battery. You can go up to a level 2, which gets all the way up to 240 volts and 80 amps. Higher charging load, but quicker charging time. And then the ones that are coming onto the market fast, and I think the ones that will be used the most are actually the DC fast chargers. And again, those things go all the way up to 480 volts, 3-phase, and even more than 100 amps. Those ones, will, if you look at the charging time down there, clearly, huge difference in the time to charge a battery on an electric vehicle with a level 1 to a DC fast charge, and that's going to be a huge factor in being able to utilize your DC, your vehicle effectively. Next slide, please. Again, we talk about AC and DC. Just want to do just a very simple slide here on the difference between the two. Essentially, the big, all the electricity that's on the grid that comes from the utility is AC, all of that. The difference here is when either you have your converter on board the vehicle, where it's taking the AC and converting it to DC on the vehicle and then putting it in, feeding the battery, or the converter is actually at the charging station and it's converting the AC at the charging unit and then feeding DC charge directly to the battery, hence the quicker charge time. Next slide. One of the other things to keep in mind is the experience with charging a battery electric vehicle is somewhat like charging your cell phone, but it's not like fueling a truck, a liquid fuel truck, where you turn the pump on and it's going to fill at the same flow rate from the time you start it almost to the time it shuts off. The only variable might be if you have many dispensers and everyone's filling at the same time, it might put a little load on the actual the pump that's pushing fuel through those, the liquid fuel through those lines, and you may experience a little slower flow. But other than that, it's the same rate. Whereas with charging a battery, it's a little different. I suspect it's, this is the DC fast charge curve where it kind of shows, initially if you had a battery that was drained, it charges and gets to a maximum charge rate pretty quickly, and then it starts slowing down and then really tapers off, and the last 80% of charging is the slowest. and it'll take the longest time to protect the battery and other stuff on board the vehicle. So just want to kind of put this out there to provide like some very basic perspective here. And if we could go to the next slide, I'd like to kind of leave it out here and really get into some questions for our panelists out here. And so I thought I'd be most appropriate really to start with Tina. And Tina, being that the NIST has had the National Work Group on Electric Vehicle Supply Equipment since the inception, since we were discussing this coming into the marketplace, can you share with us a little background on just the formation of that group, the work that they've done, and how they've actually brought that proposal to the conference here and kind of where we are right now? I was hoping each of our panelists would spend about 3 to 5 minutes at most on this lead-in question. We're not going to use a timer, but we start with that. That gives everyone an opportunity to kind of share a little perspective from their background. And so I'd ask the audience just to allow them to answer this first question, and then we'll open it up for questions from everyone. So Tina?
Thank you, Mahesh. Can you hear me?
Yeah.
Okay. Thank you first for inviting us to be part of the panel and the conference as well. We have been involved in this for quite some time, as have many other members of the community. So thank you for the opportunity to share where we've done work and where the community's done work, we meaning the work group. As Mahesh noted, NIST did establish a U.S. national working group back in 2012 at the request of the community. Oftentimes NIST will get requests from regulators, industry, the national conference, asking for us to lead an effort to try to get people together and develop either a code or a test procedure or some other standard. And the operative word there is get people together, because the most successful work in these areas is done by groups of experts rather than one individual or one entity developing things and moving it forward. So I want to emphasize that the work group is very much a collaborative effort. It was established back in 2012, as is typically the custom with the NIST work groups, is we tend to put a notice in the Federal Register as an effort to widely disseminate and make known that the work is getting ready to take place. Certainly we were integrally engaged with the National Conference on this work as well, since we did receive requests through that organization. And we established that group in 2012. I'll give a shout out to Mark Butler, who was with NIST at the time. He did a lot of the groundwork along with Juana Williams of our office. We established that work group in 2012. And I want to give a shout out to the state of California. They did some very heavy lifting in terms of hosting the work group and giving us a venue to operate, gave us facilities every time we wanted to meet. And the work group really did roll up their sleeves. We had regulators as well as members of industry, manufacturers, users of the equipment. We really did some intense work for several years. 2012 we formed. By 2013 we had come to the national conference with a request for establishing a method of sale. Mahesh, you actually primed my comments very well. The work group realized early on that time alone was not an adequate sale for the sale of the electrical energy, for the reasons that Mahesh noted in his slides, in the slides that were provided, the Ivesco slides. So the work group did recommend, and the conference agreed, that the method of sale is by the kilowatt hour. One of the things that the work group also noticed was that for various reasons, time had been used as a method of sale for many of these charging stations, and we believe from the input that the work group received that was prompted by two main things. Number one, time seemed to be a convenient way to make these assessments for up until the point where things started to get commercial, and oftentimes states had public utility commissions that may have regulations that would prohibit the resale of electrical energy. And a lot of that has changed since then. The work group has monitored that over time. And actually, I'll mention Mike Nelson of our office. He's on detail to our office here. He's been doing a lot of studies on what do the regulations look like around the country. So stay tuned for some publications that he's going to be putting out that will share that information. But the work group realized that, that the method of sale with kilowatt hour was a starting point in terms of electrical energy, but we also recognize that time could become a factor if I pull my vehicle up and I'm going to charge and I have a slower charger. I might be there for a while, and other customers may be wanting to come in and fuel their vehicles and not take up that space. So time is permitted for the vehicle to be parked at the charger. So you will note when you go into the code that there are two possible methods. One for electrical energy, must be on kilowatt hours, but it can have, in addition to that, a charge for the time. And fortunately, Handbook 44 already had a code for timing devices, so you'll see a connection to those two codes. Moving forward to 2015, again, the work group steadily worked on this, and in 2015 came to the national conference and requested the adoption of a tentative code, which was successful. The tentative code versus the permanent code, it's a bit of chicken and egg. You want something in place, but you want to be able to try it out. So the tentative status of the code allows the community to do that, to start testing, looking at equipment, seeing whether we've got things right on the code. Unfortunately, sometimes that delays people from trying the code out as well. But be that as it may, the code went into effect as a tentative code in 2015, and we were happy to see that in 2022, this past July, the conference did update that code to what is called a permanent code. And Mahesh, you also mentioned that we're constantly tweaking and revising codes. That's true of all of the Handbook 44 codes, even codes that have been in place since the 1918 when the handbook first was published. Technology changes, marketplace practices changes, the needs of the community change. So just like every other code, we expect that there will be tweaks and modifications. If you look at the S&T Committee's agenda this week, there are a number of items on that agenda looking at changes to the requirements. So keep your eye on that and just be aware that we may need to make changes as we go along. But the work group thinks, and the conference has agreed, that we think we have a really good product to start with this and move forward. The work group also has developed test procedures. We have an EPO that's been circulated for several years now, also coming out of a subcommittee of the work group, and we will be going back and updating that EPO for both changes that have been made to Handbook 44 that were adopted last July, as well as what we're learning in terms of testing criteria and procedures. The National Type Evaluation Program, and I don't know if Daryl's in the room because I won't speak to this, but
Daryl's on our panel.
Oh, there he is. Sorry, Daryl. Daryl will probably speak to the fact that in the midst of all this, NTEP has been very active too in developing a checklist to allow NTEP to test to the criteria in Handbook 44. Our office has begun developing training for EVSEs, and we expect to collaborate with others in the community as well as the work group on that. And then lastly, I want to note, if you look at our latest newsletter, at our last electric vehicle fueling work group, there were several people who asked if NIST would help in the development of standards for the test equipment. So Handbook 44 are the standards for the commercial equipment, but as many of you know, there are also standards that apply to the test standards that are used to test commercial equipment. So we are forming a new group that's not part of the U.S. National Working Group. It's a group used for that is similar to what we use for the development of our Handbook 105s, which apply to things like test weights, improvers, and so on. And Dr. Tony Latorja, who's with us for on detail, she and Katja Dalak will be heading up this group and will be reaching out. We've already had people, I see Theo there in the room, we've had people in the work group say, yeah, yeah, I want to be part of that, I want to help out. So we expect that we'll be getting a straw man together fairly quickly and then reaching out to others who may want to participate in that work, all designed to make sure that we're getting standards out for the test standards. Foremost in everyone's mind is the capability to do DC testing. So that'll probably be a primary focus of that group, although we will also document the criteria for AC test standards. And the criteria typically includes design standards. They're not design specific. We certainly don't want to restrict technology, but if you look at our 105s, they provide guidance to the people that are manufacturing those test standards. This may come out as a 105, it may come out as a special publication where we're not at that point yet. We'll see how that work group evolves.
Great.
Thank you, Mahesh.
Thanks, Tina, for that overview, and we'll certainly get back for more questions. I thought I'd go next to Kevin Schnepp from California. California was the first state to actually start dealing with this, deploying the infrastructure and the vehicles. You got the most vehicles in the country. So just wanted your thoughts, perspectives real succinctly, just to lead the conversation off on lessons learned being the first.
Thank you, Mahesh. As most people know, that California did take the lead on this issue and had a major role in the development of the tentative code. But as soon as the tentative code was published, we immediately began conducting outreach in 2016 to establish regulatory requirements for the commercial market for electric vehicle fueling systems. And that took a very, very long time because the code was new, the technology was evolving rapidly, and this is one of those situations where some of the infrastructure in the marketplace was already existing, but it wasn't commercial, and then it moved to commercial. So you took a non-commercial system that we had no regulatory oversight over, not even registration fees or anything, and then it went into commercial. And then, so it was let's just say it was turbulent. And as this continues to evolve in your jurisdictions, just expect that it will be turbulent. The technology is moving faster, and on the earlier slide, it showed that, typical DC fast charger, 350 kilowatts, well, they're testing and designing systems with more than twice that capacity now. That's a huge amount of energy. So you're going to have challenges in training, testing, oversight, and just the sheer volume of devices. And then the car sales. In 2021, I think California EV registrations were over 250,000 vehicles. Well, we already surpassed that in 3/4 of 2022. The fourth quarter data is not in yet, but we already beat that in 3/4. So the demand is there. I think California's fuel prices might support that too, but we have 28 million registered vehicles in California. So as this marketplace continues to grow and evolve, the regulatory oversight of a network of charging systems is going to surpass our 12,000. It already surpasses our 12,000 traditional fueling stations in the state. So it's coming, and it's coming to you soon if it's not there already. So get prepared, get on board, learn everything you can, and participate. The working group is still ongoing. There's a lot of nuances to this technology that are different. And for those that worked on the early development, this was a blending of codes, if you will. We had the fueling codes from motor fuel devices. You've got the watt-hour meter, and trying to figure out how to make this work was difficult. And then with everything that we do, once you get into the field, start testing and start regulating it, there's going to be changes. So we need to be adaptive, but also remember our fundamental tenets that what we do is to promote and provide equity in the marketplace. So just keep that in your pocket anytime you're talking about adopting regulations or changing the handbook, and make sure that we're keeping to our core values.
Thanks, Kevin. Early last year, I got to go to the NUMA meeting, and Kevin was out there, and he kind of shared their perspective and some lessons learned on actually getting out there and testing equipment in the field. And so I thought we'd go to the other coast, go to New York and see what Kevin's thoughts and experiences have been from this last few years of getting out and actually testing, and any other things you want to frame this discussion with.
Yeah, great, thanks. Test.
Oh, Jim, I'm sorry. I said I was bad with names. You're going across to New York, and Jim Willis.
Thank you, Mahesh. Real pleasure to be up here too, to share experiences. Kevin spoke to the overall setting up the infrastructure of enforcement actions and laws and regs. New York has taken a little bit different approach, more of a boots on the ground approach. As Mahesh mentioned, we did give a nice slide presentation at NUMA, and that was very well received. From our perspective, when we first started, and it was pre-2016, before I was even in the office, I'll give kudos to Mike Sekula getting his hat in the ring early, purchasing a test equipment, and really some of the lessons that were just smack dab right in the faces. We want to look at this in the perspective of everybody's so familiar with gas vehicles. Well, we'll test them just like we do everything else. It's not the same. You got to throw that idea out the window. You're testing something that you cannot return the product at. You have to pay for the product. So boots on the ground testing, where are they? You learn really quick how to find them on your apps. You have to set up apps in order to pay for the systems, to activate the systems in order to test them. Each system operates a little bit differently. How do you access it? Your test equipment may be, and I'm not saying in a bad way, a little quirky. Sometimes you have to push the button first, and not. So you have to roll with the punches with that. As Kevin said, adapt. Really, real important. You know, to not get frustrated with some things, because sometimes what we found is about 10% of them are inoperable. And to back up one little step from that, you go out and to test it, and you walk into the parking lot where it's at, and the building owner is there, comes out and says, hey, what are you doing? Oh, we're testing your thing. Well, that's not mine. They came here and they put it in and they told me about it, and okay, great. He doesn't know anything about it. Who do you contact? You got to contact the manufacturer, or who's ever on there. Marketing requirements, that's another thing. First out of the gate, marketing requirements were woefully inadequate. And when we talked about the minimum measurement quantity, if you're familiar with the handbook at all, how to measure that, how long do you do the test for? So we were, developing, we were, as the term goes, we were learning how to fly the plane as we were building it. So you have to roll with that. So your forms you're using to fill out to keep track of what you're doing, constant. I mentioned that it was probably 15 or 20 revisions. What do we think is important? That's really we've come a long way, and the industry has come a long way. We mentioned the difference between time and selling by kilowatt hour. Pretty much have solved that issue, but again, constant changes.
Thanks, Jim. I thought we'd go to our next regulatory person here, Mark, who's on the kind of in the initial stages of working on regulations and a regulatory program for EV SE. And I wanted to ask Mark if he's, the value you see with having the codes and standards already in place as you move ahead with your rules and such.
Yeah, thank you so much, Mahesh. The state of Vermont is in a very preliminary motion, hopefully moving forward. We are dealing with this as an initiative, a state initiative that's going to the legislature with full agency support in hopes of getting testing equipment in another position to move forward on this. I know Jim touched base a little bit on some of the challenges that are out there, and I'm seeing and hearing feedback of consumer protection issues, equity in the marketplace, issues between manufacturers and those who are installing the devices, those who are really cognizant of these rules and regulations and what needs to be met, and those who probably aren't so much. And the consumers are finally starting to pick up a little bit and look into some of these issues and to give us some feedback. And what I did want to do was briefly touch base on parts of a consumer complaint that came in to our office, because I think it really speaks to what the consumers are seeing out there, and perhaps some of the frustrations that they have, and what maybe we as regulators, when we go out and start to do some of our initial inspections, are going to also see, and some of the things that we're going to deal with. So I'll take like 2 minutes and hit on some of the highlights on this, because I think it really illustrates a number of things. So I'll start on this consumer concern. Please see the attached photo showing the charger signage. It indicates that the cost is dependent on how many minutes you charge for. In reality, once you start a charge session, you cannot stop it. The stop button does not function on the charger, which is the only way to unplug your car. Otherwise, the charger is mechanically locked to the car and cannot be unplugged, except by pressing the emergency stop button, which is not intended for normal operation and is intended for emergency situations only. When you do this, the charge session does not stop and you can unplug your car, but the charger will bill your card for $12.50, the amount for a 30-minute charge, even if you only charge for 4 minutes. And then stop the charge session using the e-stop button if you were to do so. Much less tech-savvy drivers would not know how to stop the charging session at all and would be stuck at the charger for the full 30 minutes as the cable simply won't unplug. This happened to me and a coworker in the past several months. In my case, I emailed and eventually got compensated with a gift card. However, I believe this is not something the vast majority of drivers are likely to do, even if they notice the extra charge in their credit card bill, and as a result is making significant extra money via electric charging. I'll skip around a little bit, but the closing comments from the consumer include, I am immensely disappointed but not particularly surprised to see that this station is moving into the EV charging industry immediately with practices costing consumers and taxpayers money. I believe these experiences also ultimately hurt the public's perception of the EV charging grant and the experience of driving an EV longer distances. And the consumer was very savvy. They saw the charger and they were able to link this charger, it's a level 3 charger, and it was paid for by grant money from the state of Vermont. And they were able to list where the money came from and when it was installed, and their disappointment that taxpayer money was used to install a charger that obviously doesn't work adequately. If you look at this one complaint from a regulatory point of view, we have issues perhaps of suitability of equipment, malfunctioning equipment, obviously overcharges, and what I would define as a violation of Handbook 130 method of sale regulation, where it really should be a kilowatt per hour charge. So even without having a testing unit and going out there and actually plugging it in and testing, there's a lot of regulatory work, consumer protection work, equity in the marketplace work that can be done on a very basic level as we go out there and move forward. I have a number of steps I've outlined. If we get the funding, it's contingent on the funding and support from a higher level from the governor's office and initiatives of how we might be able to put in and start a preliminary regulatory program. Number one on my list is education. Education to consumers, but education primarily to start out to the EV locations, the owners and the operators, that these laws and regulations even exist. Because so many of them, I know Jim's done a lot of work, he's done the legwork on the timing issue and made great progress. We have not done that yet in my state. So it's going to be a lot of work to do that, and it'll be a challenge. I think we're on the ground floor on what is going to be a really exciting movement toward a lot more electric vehicles and a system out there. And years from now, you can point back to us being on the ground level on this with a lot of enthusiasm and excitement. So I'll leave it at that, but I'm available for questions.
Thanks, Mark, for your perspective. And on that consumer complaint, like all of y'all know, we get several hundred consumer complaints on the liquid fuel sides, and there is an element where there is a need for consumer education too. I think more so with operating an EV charging station and location and how to disconnect and all of that, because the experience is not exactly the same. I thought I'd go to Francesca to kind of, if you could let us know, like, how should regulators deal with existing infrastructure that we've talked about that's already there, and how are EV charging owner-operators going to be involved and engaged with states?
Yeah, and thank you for the opportunity to be on the panel. There's already been a lot of good stuff said, so a lot of things to respond to. But in answering the question, one thing I did want to point out is there is, a lot of discussion around fast charging these days, and that being sort of the growing market. There's a lot of infrastructure funding going into that. And for us, one thing we always have to keep in mind is charging. We sell cars, right? We're a manufacturer of electric vehicles, and we're in the charging business because we know in order to sell cars, we need to be able to offer a reliable charging experience. And so we think about how to best integrate that into the customer's life. And so for us, even though we emphasize fast charging, the best place to charge, right, is still where you park. And so fast charging for our customers represents only about 20% of their charging needs. 80% of the charging is done where you're already parked. And so when you're parking to charge and you're going to be there for several hours, that's a fundamentally different experience than when you go to a fast charger. And I mention all of that because the emphasis on AC charging and the code coming into force for the AC side, from my perspective, is actually much more important today because the population of chargers that is out there on the level 2 side is so much greater and growing, and it's where a majority of the charging is still taking place. So in terms of focusing on existing infrastructure, that's where we're placing our focus. And we've had the pleasure of going through the California type evaluation process with our wall connector, which is our level 2 product, and sort of realizing, what does it take to go through type evaluation, and now thinking through how do we do that in the field as well. I'm not saying DC charging is not important, but I think it's just an important way to distinguish between that. And California, Washington, and Oklahoma have all thought about how to deal with existing infrastructure in different ways. That's obviously a small, population of states, but there are models out there to think through that. So just keep that in mind when you think about the customer side of things. And then just generally, I think to the point of charging on a per kilowatt hour basis. So over the last several years, the industry spent a lot of time going through to each Public Utilities Commission and asking them to clarify that when you sell power to a customer, sale for resale, you're not going to be subject to Utilities Commission regulations because you're not a utility. And so 43 states now have clarified that, and that's why we can have sort of the regulatory certainty to move to the best model, which is billing on a kilowatt hour basis where it's appropriate. So there's sort of all these different bodies, right, that have to work together here to make this all work. And for us, the final question I'll just point out, for existing infrastructure, there's a lot of safety questions and reliability questions. If you're in the EV charging infrastructure world today, reliability is the #1 topic that comes up. And there are a lot of entities that regulate portions of that. So when we build a fast charger, we have to work with the utility to get a new service connection, right? They're checking the electrical part of that. They want to make sure we're safe to operate. We're working with a local jurisdiction, city or county, to get a permit to operate that site. So they're looking at electrical code, NEC, all these different things. So I mention all of that because I think this conversation is really important, but it's a small part of the puzzle. And so part of some of this discussion will also be, how do you work with the local city or county on some of these other issues, and how do you collaborate on that? So looking forward to the conversation and questions.
Thanks, Francesca. Thought I'd go to Keith next, and we heard about the different models, business models that are being used. Who's responsible for weights and measures compliance for the charger?
So I want to reiterate the thanks for putting this together. So I am an EV driver. I drive a 2019 Nissan Leaf, which is kind of an entry-level car, but awesome. I highly encourage you, if you can get your hands on an EV, they are great to drive. But my experience of charging lines up with what Fran described. And it's not just a question of what is the installed base. There are lots of reasons why AC charging is going to continue to be quite prominent. So in my own life, I have a charger in my garage. That is where I do most of my charging. I use fast chargers when I'm on a long distance trip, or if I have sort of planned in such a way that I'm just out and I just need to charge, that I wasn't planning on. So I do that maybe once every couple months, right? There are two big sort of spreads that are going to look a little bit different from gas stations. One is this fact that there are AC chargers and DC chargers and this array of charging speeds. I imagine that gas pumps mostly fill at kind of the same rate, except where there's industrial scale gas pumps. But if you think about it, an AC charger that is going to operate at 7 kilowatts, I just want to talk about math for a second here. So the minimum measured quantity might be half a kilowatt hour. The thing charges at 7 kilowatts, and you are supposed to do your test, one of your tests, at 10% of the maximum current up to twice the measured quantity. So let's hear 7 kilowatts, 1 kilowatt hour would be 1/7 of an hour, except now you're doing it at 10%. So you're looking at about 1 1/3 hours for that test, which is one of the tests you're going to do in an inspection. So you can do the math on what inspections of AC chargers is going to look like, right? And then at the other end, you have DC chargers, which are going to charge much faster, and you're going to kind of like roll through them. The business models are also going to be quite different than what you're going to see in the marketplace. So if you were to go to Tesla or an Electrify America, you're going to see typically a bank of chargers that are going to be in a parking lot somewhere. It'd be the most common configuration. There are other business models where you might see one charger right now at a gas station. And then for AC charging, it's much more common to have those, one or a few lined up in a parking lot somewhere at a mall or at somebody's workplace. And there's much more diversity than you would be used to in seeing, like, I know where the gas stations are. I go to the gas station, there's the pumps, right? So who owns those is going to vary. Electrify America, basically we own our chargers. Tesla owns their chargers. There are business models where somebody will sell the charger to a site host and then essentially operate it. And there are business models, and a lot of times there will be these site hosts. I think about in my small town, in the downtown, there's a couple of municipal parking lots that have chargers installed, and I guarantee you the town doesn't know that much about operating them. So there should be a phone number labeled on the charger, or like a QR code or something that you can find, and I would really encourage you to call that first. We do, Jim, you mentioned how the site hosts don't necessarily know anything about it. We have that experience too, where somebody will go into the site host, and of course the site host doesn't know. Call that number first, because the person whose phone number is on the charger, that's going to be what we call the network operator, is going to be the place, and this is another really big difference from gas pumps. These are going to be unattended. Even if it's in a location where it's at a store, where there's a store, you could walk in and there's a person there, that person probably doesn't have anything to do with the charger. So think of them all, your default assumption should be that charging stations and chargers are unattended, and you need to call the number that's on there. And both for questions, to be able to work out this question about how do I pay for it, because obviously you're going to be buying a lot of electricity if you don't work that out. All of those questions, call that number, use the QR code rather than go into the site host, because they probably don't know.
Thanks, Keith. Thought I'd go next to Joseph, and we've seen the Tesco chargers out here in our foyer for several of our meetings here on the AC side. Can you speak to the DC side and what y'all are doing, and maybe just maybe some cost stuff too?
Yep. Hello, everyone. So like you said, we sell AC charger, not AC chargers. We sell test equipment for AC chargers. And before I continue to talk about DC, I just want to put into perspective. An AC charger at most can draw about 240 volts, 80 amps. That's about 20 kilowatts. A DC fast charger can go up to 350 kilowatts. That is 10, 15-ish times more powerful. So you guys saw the T4000. If you didn't, you can look at our website and see what it looks like. The load box there is about 40 pounds and it weighs 40 pounds and it's about like yay big. And that burns about 14 kilowatts. So to make a DC charger tester, you would need about 12 of those. That's a lot. That's not a handheld equipment. That's something that gets mounted in the back of a truck or something like that. So what is Tesco doing about DC charging? Well, we're working on something that's a little more modular. In the past, it was like, okay, you guys need in order to test DC chargers, we need to test the full 100% capability. And that's about 200 at the time, 200 kilowatts, and now 350 kilowatts. Another perspective, that is more energy than your house can draw. That's about more energy than 5 houses can draw. It is a lot of energy. A lot of power. So we said, okay, let's start working on this. The regulatory changed to say, okay, we only need to go up to about 100 kilowatts. And we're like, okay, that's great. That's actually pretty small. We can build a handheld device. And then it moved back to, no, we have to go back to 100% testing. And it keeps shifting around a little bit because this industry is still relatively new. This marketplace is still in its infancy, and it's going to change and develop and grow as time goes on. So our solution now is to make something a little more modular. Hopefully we're going to have something by the end of the year, and the current cost of the equipment is about just under $50,000. Once DC charging, our test equipment for DC charger comes out, it's probably going to be larger than that because you guys see the picture of this truck, you see the equipment in the back, it's going to be something along that size, physically that size, weigh hundreds of pounds, and it will obviously cost a bit more. If you guys have any questions afterwards, please feel free to reach out, talk, we can answer questions and talk about details and specifics.
Sounds
That's
good.
it.
Thanks, Joseph, for leading in with that. Daryl, I'll go to you finally here before we open it up for questions. And we know NTEP's issuing certificates of conformance based on test results for devices that have been evaluated by California. And you continue this practice now that the tentative status has been removed in handbook. If yes, will NTEP issue a certificate of conformance for DC chargers?
Thank you, Mahesh. Good morning, everyone. Yes, NTEP does accept the test data from the California laboratory, California Type Evaluation Program. We have done so. There are 2 NTEP certificates that have been released. There are 4 in the pipeline right now. The decision to accept the test results from the California laboratory was very easy. The California laboratory is also an NTEP laboratory. So California jumped on this early and fast and got ahead of the game, so they were in a better position to start doing the testing than NTEP was. So their codes are a little bit different, but the tests are basically the same thing. If they wouldn't have jumped on it as early as they did and NTEP would have been ready to go at the time, the evaluations would have been assigned to the California lab anyway, so there's no issue there. The only thing we do have to watch is there are some slight differences between the California Code and Handbook 44. And then, of course, that rolls down into the test methods, slight differences. But the differences are so simple that NTEP can handle them working with the manufacturer through photographs or a quick Zoom meeting or just, in some cases, even just a phone discussion. So it's not a problem at all. There's no differences. There's no question of which certificate is better or anything along those lines. They're really the same. Now, again, I did mention there are some differences, so we're in constant contact with the evaluators in the California lab, because you always, when codes are slightly different, when test methods are slightly different, you always get interpretation issues. We've never run into that before in Handbook 44, right? So there's always some slight possibility of interpretation issues. So we're in constant contact with the evaluators in the California lab. When they come across something of this is how they interpret it, maybe INTEP interprets it slightly different. We work through it to try to come to a consensus and agreement that satisfies both of us so that we can keep moving forward. Now, that doesn't mean that INTEP is going to continue to, I almost said that wrong. INTEP will continue to accept the test data from the California lab. But I'm always concerned when there's a single lab to do an evaluation. What if my customer sends me an application and says, I want to get my charger evaluated, and I contact the California lab, and they say they're backed up for 6 months? Man, the last thing I want to do is go to my customer and tell them that. So INTEP is looking at how do we handle that. We do have an INTEP specialist on board that I've assigned this to. I also think that there's a great opportunity to evaluate these devices at the manufacturer's facility. So that means we wouldn't have to have all of our equipment in an INTEP laboratory or in my garage, and then do the evaluation there. We can come to you and do it. So we're trying to bring that gentleman up to speed, have him scheduled to hopefully go to some evaluations, actually go and spend a day or two in the California laboratory and become familiar with this and bring us up to speed so that we don't put our customer in that situation. So the plan is to continue to accept the CTEP or the California Type Approval Test report for issuing INTEP, dealing with the nuances. INTEP also participates as an observer in the national work group that Ms. Butcher talked about earlier. We participate as an observer because we just want to see where it's going. Where are the standards changing? What are the manufacturers talking about? So that we can kind of anticipate what changes we might have to make going down the road in our evaluation process. We want to be proactive, not reactive. The next question that comes up is DC. Yes, INTEP is going to accept the test data from the California lab for the issuing of certificates for a DC charger. We've already got California is evaluating some. We already have we being INTEP, already have received an application to follow up on that. So when California is done, we can issue the INTEP certificate working with the manufacturer. So that's, we're going to continue down that path. So.
I guess now I really want to go to the audience. I think that's really what this was set up for, and to get questions from y'all. This is not an open hearing, so you don't need to come up to the mic and state your name and all of that, but it would be helpful to come up to a mic or to speak loudly so that others can also hear your question. So, anyone? Don't feel shy. You can ask it to whoever you want to.
Sure. All right. Well, thank you all for being here. I'm wondering if anyone has done any work or outreach with your local electrical unions, the IBEW, and if so, how's that been going, or do you have any recommendations? Thank you.
Well, in California, we, as many of us regulatory programs have, is we have a registered service agency program. And California has a state-county system, so we have 55 county jurisdictions of weights and measures, the state kind of high-level oversight, and the RSA program. And that's essential just to manage the sheer number of devices. And one of the questions we had was from an electrical contractor who says we kind of have a place in service requirement for the RSA, but they were just doing infrastructure work, putting everything up to the point of connection, and that was their total involvement. And they thought, do we have to license and register our people as RSAs? And we had explained to them that, no, if you're not what we call energizing the device, so when you leave, can someone use it commercially? And they said no. So we addressed that issue, and they were very happy to that point because of, the sheer cost. There's not just one or two entities, there's several hundred entities with several hundred employees. And they didn't want to, number one, pay all those licensing fees and registration fees, but also pay to take the test and then train people on a test that really doesn't apply to them. So we did address it from that aspect. Also, we have an interagency transportation electrification working group within several state agencies, the California Energy Commission, the Public Utilities Commission, the California Independent System Operators, which control our grid supply in the state, our department, Measurement Standards, the Air Resources Board, working collaboratively to make sure that as we roll out this technology and start to regulate it, that we're not inhibiting it, but we're not letting it grow into a system that we can't control. So working out with the union contractors, the electricians and the electrical contractors, making them understand that if you're doing the full installation and energizing the device, yes, you have to be an RSA. There are certain requirements that go with that. But if you're doing infrastructure work, not connecting a device, not turning it on, you don't have to be. And that was a huge relief to literally, companies and several thousand employees.
Thanks, Kevin. Jim?
Yeah, Craig, New York State does not register or license installers or service technicians, things like that. We do not have a registration fee or system for devices. Some counties do. We have a notification of install. So with that, we rely on the electric safety and code and their safety aspect to make sure that they're correct when they run their lines.
Anyone else want to weigh in on that?
Actually, Craig, I'm not going to answer that question because I don't know what Electrify America does in that respect, but it prompts me to talk about something related, which is safety. I hear concerns occasionally about, how do I know that the charger is safe? There's 1,000 volts in a fast DC charger inside the box. How do I know that it's compliant with electric codes, et cetera? So the thing that I wanted to let you know is you are not the only people to be looking at these devices. So the charger will have been through a local building permit process and inspection. It will have been through the utility coming to energize it, and I can tell you that they do not, hook up, the 350 kilowatt, 1,000 volt devices to their distribution grid without also looking at it. So there are several checks that happen on the way to make sure that these installations are safe and functional in the electrical sense. And the other thing is I just wanted to, there's a feature about chargers that was brought up to me about what Kevin said. The vast majority of chargers that you're going to deal with are networked. So they are under some degree of control from some central back-end server somewhere that is communicating out the price, handling the sort of the credit card billing, something like that. That is a feature that's important to know about as you inspect them, and is also a benefit if you think about, how am I, again, call the people who are the number that's on the station. That's probably who's going to be operating it as a networked charger.
Thanks, Keith. Vince?
Two questions. Yeah, two questions. One, with the DC fast charging, some of that energy is diverted to help cool the batteries and the system as a whole. Is the customer made aware that some of their power is being diverted to do that, and they're actually having a loss of power? It would be more economical for them to have the batteries charged at a slower rate. Is there labeling or anything like that in line for that? And then also, for calibration purposes, is it done remotely? And is there an audit trail that we can see, or is it typically just a failure of the system and the system has to be repaired?
Okay. I can't talk much about your first question, but I can talk a bit about the second one, which is calibration and audit trail. So something Tesco worked on is a 17025 certification. It's essentially like the highest form of certification that you can get to say that, yes, we are calibrated for DC, we can prove it, we have statistical data, we did a lot of math, we know that our units are accurate, and right now it's not NIST traceable. Once NIST gets that, then it'll be NIST traceable, but it's essentially the equivalent. And our equipment actually can do AC and DC, and it will provide that traceability that you're asking for. So we sell the equipment to utilities or to regulators. They use that equipment to test the charger, and kind of like if it was a gas pump where they fill it up a certain amount and they give it a thumbs up or thumbs down. The guys who go out in the field would use our equipment, test it, and say, yep, this is good, and they put a sticker of approval at this date, this time, this tester tested it, and it's approved. Or if it fails, they would contact the phone number, the number that's on the charger, and say, hey, this is out of compliance. This isn't safe. Part of the testing is safety testing. We actually, it's not just accuracy, it's also safety. So, we induce a ground fault intentionally. And we slowly increase it until eventually the GFCI trips and it cuts off the charge. And we say, okay, at what point did that happen? It should be under 20 milliamps, but if it triggered only at 30 milliamps, hey, this unit is not safe. It could electrocute and hurt someone. So we do those safety tests as well as the accuracy testing, and we provide the traceability through our equipment.
And Vince, maybe to the first part of your question, which was the actual charger at a charging station. There's not a lot of signage on the unit itself to educate the consumer as to when to charge and all that. But on the vehicle, on most vehicles, you can tell at what percentage your battery is at, and so a user would know when might be the optimal time to charge.
So to clarify those two questions.
I got you.
Okay, thanks.
I think his question was specifically to the chargers themselves and the design. So we've type evaluated and approved, I think, over 14 AC, and we have several DC in the works right now. And for the most part, as far as an audit trail, yes. But the calibrations and controls or calibrations thereof, many of these units are designed with a completely sealable system. So it's sealed at the factory, and it cannot be calibrated in the field. And if there's an issue with the charger, they're going to basically, with some designs, basically pull the head off of it and put a new one in. But if that happens, there's also a sealable parameter for that. So the weights inspector will know that, hey, this has been replaced. Which, again, if you have a service agency program, they're required to notify us in 24 hours that that's been done. And then it's up to the inspector to go up and verify that. But also, if there is a field calibration component or an upgrade, there's an audit trail that's a requirement. There's a sealable parameter that is part of the type evaluation.
And I'll just add on the RSA process, Tesla itself is becoming an RSA for that reason, in order to be able to do that work. And all of our certified installers will also be RSAs, so we are able to have sort of that direct line of communication. Because we do have to go work on the chargers, there are certain issues that come up, and so we don't miss anything in that instance. So it was easier for us to become an RSA.
Yes, thank you. I did want to touch on something that Vince had mentioned and that I think was brought up, and that is the safety issue. I'll make a comment and then I'll maybe ask a question if anyone wants to elaborate. Is one of the issues that has come up in the discussions of the work group is the safety during inspection and testing. And the intent of the work group in its discussion was that this should be a plug-and-play type of thing in terms of the testing, that it was never intended that the inspector would have to do anything other than do the same thing that a customer would have to do in terms of connecting to the testing equipment. That was the intent. Now, I ask kind of a question, perhaps of the manufacturers of some of the test equipment and perhaps some who have more experience installing and using, but that's a question that has come up a lot to us as well as the work group in terms of when an inspector goes in, do they have to have special knowledge or electrical background or skills, but the intent was to be a plug-and-play type of thing. Thank you.
To answer that question, we designed our equipment specifically that your average Joe Schmo who doesn't know anything about electricity or what's going on, there we go, we got one right there. He could just operate it, and we try to build the software that way, but also the way the equipment is used is supposed to be just like a vehicle. So your average Joe Schmo, drives up their vehicle to the charger, takes out the outlet, plugs it into their car, maybe swipes a credit card or uses a phone app, and away you go. You don't need to do anything else. The equipment is built to operate in the same manner. There's no safety requirement, no safety PPE gear, right, personal protective equipment, gloves, none of that. The idea is it's just like a vehicle.
I wanted to come back to Vince's other question, which is about the battery energy being diverted. So for those who don't know, what he's talking about there is, so the energy comes out of the end of the cable, gets delivered to the car, and the Handbook 44 standard is holding us accountable for how much comes out of the end of the cable, that point of connection to the car. Inside the car, though, that energy is not necessarily all increasing the state of charge of the battery, because some of it, in many cars, is going to be used, for example, to cool the battery during the cooling, the charging process. Charging heats it up. As it happens, in the Leafs, there actually is no active cooling, so it doesn't happen to me. But it is hard to predict in the abstract how much of that is going to go to cooling of the battery, because it depends on the vehicle, depends on the state of charge, everything else. And this brings up a larger point. As Mahesh said, there's going to be an indicator in most cars, and unlike a fuel gauge, these indicators typically read in like 2 significant digits. That's not real. I'll tell you, my Leaf, it tells me that I've got 85% state of charge, say, but the actual capacity of the battery is declining over time, and it's reporting to me the capacity of the battery in about 1 parts per 10. So currently, my 2017 Leaf has, its battery capacity is somewhere between 80 and 90% of what it was when I bought it. So when I look at the indicator and it tells me that it's at 90% state of charge, how many kilowatt hours is that? I don't really know. So think about that when you think about customer complaints. They are seeing an indicator with 2 significant figures, and they think that's a real number, but it's actually only precise to like 1 part in 10 or worse. That's going to drive, I suspect, a really different kind of interaction. And in addition, on top of that, there's this issue that Vince mentioned, that some amount of the energy is not going to charge the battery, but the car is using it to cool the battery during the charging. So there's going to be a different dynamic in customer complaints.
Good point. If you connect it to gasoline and some of the consumer complaints we get, it's like using the plastic 5-gallon can that you purchase from the big box hardware store and making sure that that's accurate, and they got shorted on that. Tim?
Yes, Joe Schmo from Little Rock, Arkansas. I don't have an EV. I don't want to know. I'm just not that guy. Okay. I do have a question, and you alluded to it, I think, just now. You briefly, and you enlightened me at the same time. You don't know it, but I do listen sometimes. When this meter is being tested by anyone, what verification besides the indicator in the car do I have that I know that that charge is actually going to that car? How can I verify that? Wow. I've never had an attorney stay so silent.
I have this stumped look because I'm not totally sure I understood the question. If you are doing a test and you take the Tesco box or you take the box that Fluke is developing, that box is going to report to you how much energy came out of the end of the cable. There's nowhere else for it to, if a car is plugged into it, there's nowhere else for it to go. So I'm not really sure I understand the question about understanding where.
Well, you just complicated everything right there for me, because I can't verify, stick my finger to it, that it's actually coming out of that hose. I'm dependent on something. I ain't talking about a red light, indicator light, nothing. How do I verify that it's coming out of the end of that hose into that battery? And you just mentioned that little indicator is not even real inside the car. I can't even go by that. So how do I verify that? I can see gas coming out of a pump. How do I know what's coming out of there and where's it going into the car? Is the customer getting what he's supposed to for the time he paid for or the amount he paid for? How do I verify that? I'm saying it can't be done.
Yeah, Mahesh, if I could comment on Tim's comment, there's two things I think is relevant to what you're asking, because typically with a weights and measures transaction, you see something indicated, the customer's paying for that, and you're verifying that it's going into a container, car, your bag, whatever it is you're purchasing. So from the perspective of the commercial equipment, for those devices that have an indicator, will indicate how much is going into your vehicle. There'll be test standards, which I think was what you are indicating that we typically use in the weights and measures world to say the device under test, the commercial device said this, my test standard said that, so I know how much has gone into whatever it is that I've got, whether it's a vehicle, bag, et cetera. You're right, you're not going to see it like you would a liquid volume. You won't see it like you would if it was something going into a weighed device. And as Keith has noted, what happens in the vehicle, it may not go to charging the battery, it may go to other things that your vehicle needs to operate, to charge the vehicle, et cetera, but the customer has taken possession of that and it's being used for charging their vehicle. I'll let you speak to the mechanics of the test standard, but from the process of what's indicated versus what's being purchased, we would do that the same way we would do any other weights and measures test. You're just not going to be able to physically see it.
I'm relying on an indicator light.
Or an indication. I mean, that's certainly something that the code is requiring right now. There's some exceptions that have been adopted for a period of time, but that was the intent of the indicator on the device, saying, here's how much is going into your vehicle. And I would note in a similar fashion, if you compare that with other devices where you can't really see, let's say a compressed gas, you know, I can, even LPG, I could open it up and see if it's going into the bucket, but unless the temperature is right, I'm not going to see that either.
But I can put that on scale.
Well, but I'm saying, like, to look at it, you're not going to see it. You're not going to see it like it physically like you would a liquid, but you do have a way to test it, and you do have a way to verify whether what's indicated is what is going into it. And that's where I believe you're going to talk about the test standard itself.
I just disagree. I don't want to rely on the indication of anything.
I think fundamentally you won't be able to. It's a battery. It's not like, it's not liquid. So when the battery gets fully charged, it doesn't get heavier. It may warm up depending on how fast you charge it, but if you were to plug it into the charger at home, it's not going to really warm up. There's no visual inspection that you can do that would tell you, yep, that energy delivered from the charger actually got into my battery and it didn't go somewhere else.
So I'm still stuck. I can't say with any high degree of confidence that charge is okay.
Correct. So you as a consumer, you're right. As a consumer, you have...
I mean as a regulator also.
Well, then that's where I would disagree. As a regulator, then you have to put your trust in some kind of standard, right? And our equipment, the way our equipment works is we don't put the energy in a battery. We have a heater. You would feel it, like you would put your hand in the back of our load box and it's blowing very hot air, like it feels like a toaster oven. If that energy isn't going into our toaster oven, where would it be going? So you have now a physical and visual indication that that energy is going into something and that you are paying for it, right? There's obviously going to be some level of trust. When you buy a 5-gallon, or a 1-gallon carton, you trust that it's exactly 1 gallon. Same thing here. So when our equipment says, yep, we measured 1 kilowatt hour, certain level you have to have a sense of trust, which is why we have regulatory bodies, NIST, and other things.
Well, I'm not trying to rail down on EV. That's not my purpose. I just got to have a high degree of confidence in what an inspector's doing, what's he seeing, and I don't trust because I'm a regulator. I verify. So.
Yeah.
Could I possibly, Mr. Chesser? Yes. On my phone, I have this little charge light that shows up when I plug it in. But on a dispenser, you see the numbers clicking away, don't you? But there's no rate of flow indicator on that dispenser. So maybe your question is, do I get a rate of charge that's shown somewhere? Is there a rate of charge that's being shown on the dispenser?
Yes.
Yeah.
The rate at which it's charging.
Kilowatts.
Yeah, kilowatts.
Does that help you, Mr. Chesser?
So
I'm sorry, thank you.
the other thing that I would note, the battery doesn't get heavier, but most batteries, there is, for the state of charge, there is, the open circuit voltage does depend on the state of charge. So if you have a fully drained battery, 0, its open circuit voltage will be 0. And then it climbs very rapidly as you have a bit of state of charge, and then it sort of tails off and continues to increase to the largest open circuit voltage that it will have when it's really full. In principle, and it's not a very precise way to measure the state of charge of the battery, but in principle, if you wanted to get a sense like, did this really happen or was this charging imaginary, you could check the state, the open circuit voltage of the battery and see, is this battery kind of like roughly full or roughly empty? As a regulator, you don't get to do that because you'd have to open up the car and really get into the guts of it. So you're going to use on a secondary measurement technique, which is use somebody's boxes, either Tesco's or Fluke's or somebody else's, to measure how much was actually delivered in a test process.
Jose?
Thank you, sir. Jose Arriaga, Orange County, California. And I think that was a really good example of something that, a lot of us have been thinking about, and that is the threat to the EV industry. And there are many, the grid not sustaining it, people trusting that the range on the batteries is what it says. But there is another area very important where we actually have a bit of an influence or a bit of a level of responsibility, a charge, no pun intended. That is consumer confidence. And that to me looks like low consumer confidence. In the world of all other devices, when somebody files a complaint and say, I don't think I got the right amount of gas or deli meat, they go to a third neutral party, a regulator that will go out and either show records of inspections and say, we actually tested that device a month ago, and it was correct based on the standards. Or we go out there and we verify whether the complaint is valid or not. So there is a very strong correlation between regulatory compliance and consumer confidence. In the world of EVs, I know that we've been going back and forth, and there are definitely different thoughts on we're not ready to be fully regulated. We have the OG devices, which you guys call the legacy devices. We have the new things that are coming up that may be under regulation or probably will be under regulation. But what do you think are the pros and the cons to consumer confidence to say, you know what, let's just bring everything into regulatory compliance so that way the industry as a whole can be defended as far as the accuracy, not just by you, the operator, but also by us, the regulators, because the way it stands right now, I can't speak to those older devices' accuracy, even though you do tell me it was built and it was installed meeting all the requirements, but there is no seal on it. What do you think are the pros for the industry to bring everything into current regulatory compliance based on the available technology? And what do you think are the disadvantages? And I know there is a cost to the industry, but there might be that bigger arena of general consumer confidence. Wanted to hear a little bit from Tesla and from Keith.
Thanks,
Francesca.
Who wants to go first?
Yeah. It's a really fair question, and I think it's something we grapple with all the time. So in terms of I think generally we always favor the customer, right? In any dispute or instance where there's an inaccuracy, we're always favoring the customer because we want to make sure that customer remains an electric vehicle customer, right? But at the end of the day, it's something hard to grapple with. And I think in the interim period where you don't have, on the DC side, the metering technology just was not there yet, right? So Tesla uses a different system today in our stations. We use a sensing system for our stations for metering. We're switching over to our DC meter, right? We're going to be in compliance with California. We have that product now. We're moving forward with that. And so I think, unfortunately, I don't have an answer of, there's going to be this great mass. I think the idea is to transition all those devices over as we can with time. For us on the AC side, our product was free and continues to be free. We're not switching those legacy devices to be not free. We're doing it going forward now that we have a type certificate. So from our perspective, one of the reasons we did that is because we didn't have anything in place, and we had a different business model at the time. So, but from a customer perspective, we do have processes in place where customers can reach out to us and argue about, the transaction, the history, and we have all that information because we have a closed loop system. So we know exactly what's happening with the charger and the vehicle. So for us, the confidence is pretty high that those chargers are reliable, even though, they didn't have the DC meter that we're going to be moving forward with at the time. So again, that's probably not the answer you want to hear, right? But with all technology, it evolves, it moves forward, and I think the idea that customers need to be protected is really important to us. The only other thing I was going to say is, because I brought up reliability earlier, and a lot of people talking about reliability, charging stations have points of failure, like screens, like card readers, all these other things that impact the reliability of that system. So there are going to be a lot of complaints that come that have nothing to do with weights and measures, right? They are going to be due to the fact that that system isn't working for many other reasons, and you all will get many of those complaints. So I think that's another thing, and I know California is taking this really seriously. They have a whole entire reliability standard that's being worked on in a different forum. Many states are looking at that because you're getting a lot of consumer complaints that have nothing to do with the accuracy of that system. That system just not functioning. So I wish I had a better answer, but hopefully
Keith,
that
do you
helps.
want to weigh in on that too?
So I think regulatory compliance is not for better or for worse, is not a yes/no question, because it depends what you're complying with, how you're complying, how you're inspecting, and everything else. If you have listened to me at any of these meetings, you don't hear us saying, leave us alone. Like, we agree that transparency, customer confidence, those are very important things, and we also agree that that's not going to get there by means of our saying, believe us. Like, we fully salute the role that you all play in making that happen. At the same time, the reality is, if for DC chargers, which is most of what Electrify America does, if we said compliance means that tomorrow I can't install, like, that means just treat it fully like gas pumps in the way that, like, as though this has been going on for decades, and tomorrow I can't install and commission a charger until somebody from the town, now obviously it depends on the state, right, whether it's the municipality or the state, but somebody from the county has come to test it to a particular accuracy. In most of the country, you literally can't get it done. And that is a real cost. That's a cost to us, it's a cost to customers, it's a cost to society as a whole. So those trade-offs are real. So I think the answer is, let's work together to get to a fully fledged regulatory regime as swiftly and smoothly as possible, and turn on the pieces of it as soon as they're ready, which is largely what's happening, I think, in this regulatory space, with the code coming into force in general this year, et cetera.
Thanks. Kevin?
Just a couple more points. Actually, you can do that in California, so that's part of the service energy. They can place it in service, and then we or the county come out and test it on our. But the RSA is placing it in service also, and also certifying that it is accurate at the time of installation and correct. And so that is already out there. The challenge we have, not just we in California, but everybody in this regulatory marketplace, as I mentioned earlier, is this was a non-commercial system, as they were developing it, proving it, developing the charging technology, developing the vehicles that came into commercial. They didn't start commercial. So, and secondly, in California, the vast majority of these charging stations were funded by taxpayer dollars. So if we suddenly say, yes, we want full compliance, but we tell the taxpayers, this device that we spent, collectively across the state $100 million on, has to be retrofitted, and it's going to cost $200 million. That's not going to work. Not at an administrative level, not on a department, certainly not on a department, not on a PR level, and not on a taxpayer satisfaction level. The user groups, drivers, are learning about the different performance of charging stations out there. There's a huge chat group, there's different, web groups and that are talking about positive and negative charging experiences for the station, some that are regulated, some that are not. And I think that information will grow and continue to grow. And it may be eventually the consumers and drivers of these vehicles that drive compliance faster than our process does.
Okay. Thanks for that perspective. We have 10 minutes left. Maybe, Tina, you can use this as part, I just wanted to give the panel an opportunity to, we do have.
Question. I'm a part of a scale company, and we've been looking at the EVs for a while, and we were wondering, how do we get into the service and repair portion of it? Because if you guys are going to have screens down, other things down, you're not going to want to have weights and measures come out. I don't know if right now it's just like Tesla or Electrify America that comes in and does all this, but I'm a 17025 compliant company, and we have the infrastructure to go out and service and do all of this stuff. But how do we get into it so that we can start having more charging stations that are actually working in our city and town?
Great question. I know there are service agents that are out there that service these devices, but I'll let the industry members speak to it.
Let's talk afterwards, then I can introduce you to some people. There are service companies in this space. They are mostly relatively inexperienced, simply because it's relatively new, but they exist. You're going to want to think, of course, about which kinds of service implicate metrological function and which don't, right? And there are obviously many states where that's going to need an RSA registration, and some that where it doesn't. So I guess what I would say is how to get into it is, like any other new business, you're going to need to build capacity, build customers, and get that licensing. But it is there is definitely room to grow. I think probably all of the large operators in this space use vendors for these functions to some degree, and the industry is growing.
I'll just add for Tesla, we're fully vertically integrated, so we do it in-house. Unpopular, but we don't have screens or cards or anything on our stations, so it's really just the post. Most of our service is relatively simple. We do it back-end software related. Sometimes we do go out and we have those crews in-house. But I will say, to Keith's point, with the federal infrastructure funding coming in, this is going to be a huge issue that's discussed. And so I think there's a lot of opportunity, and also not just for fast charging, but on the level 2 side. I know there's a lot of companies that are looking at this. So happy to also chat afterwards, even though for us it's fully in-house.
Ray?
Ray Woolfolk, State of Alaska. This is really for Daryl. You had mentioned that you'd recognized California CCs. By any chance, when you do recognize those, do they put it in the NTEP database?
What was the last part of the question? I'm sorry.
Oh, are they, when you recognize a California Certificate of Conformance, are they entered into the NTEP database?
The California certificate is not entered into the NTEP. They have their own, location you could find it. I just used the test data, create an NTEP certificate. It basically mirrors the California certificate, a few little minor differences. And then that goes on to our website for the NTEP certificates.
Okay, thank you. Yeah, because we're an NTEP state, and I had looked and we found one in the database that we have, the charge point. But you had mentioned that California has certified another one. Did I understand that correctly?
Yeah, and if you want to look what California's done, all our CTEP, and we have what's not a CC, it's a Certificate of Approval, or COA. All of those are available on our website.
Cool.
Just look it up by device type.
I just didn't even realize that. Thank you very much.
Thanks, Ray. Tina?
Yeah, I do have one comment. sort of to Keith's point about working together and trying to facilitate the implementation of the use of this equipment, the testing of the equipment. And I'll note that it is a new area for many weights and measures programs to get into. And a lot of times when you have a new area, there's a question about, well, can I afford the test equipment? And do I have an inspector? And so on. And I wanted to note that you don't want to use your lack of equipment or your lack of knowledge to hinder the industry from going forward. But I would like to point out that weights and measures is a regulatory function. Your role is to go out and verify that the device owner has done what they are charged to do in Handbook 44, and that is to install and use and calibrate equipment to comply with these standards. And the weights and measures role is to make sure that that's been done. So if you don't have the test equipment, there are provisions in the general code that would allow you to require the device owner to bring in the test equipment, and you can witness that testing. So don't use your lack of ability to access that equipment to hinder the equipment from going into service. You don't want to say, well, we don't have the test standard and I don't know when we're ever going to buy it, so you can't put your device into service. And that's an exaggeration, but it's not a lot different from if you have an application where it requires, let's say, a $150,000 approver, or let's say a rail car. You find ways to do your job as a regulator to verify that the equipment functions. And ultimately, the device owner is not to be putting equipment into service until that verification has been done. And they may use a registered service agent, but you can do the witness testing in order to make sure that that functions. It's a rather simplistic approach, but just to encourage you to make sure that you're working with your industry, and it's okay to ask the device owner that I'm going to put this into service. Well, how do you know that it's accurate? It's ultimately their responsibility to make sure that's the case before they start using it commercially. So I just wanted to throw that out. Thank you.
Thank you, Tina. One last question.
Anthony Lee with Orange County. So within our jurisdiction, since 2021, there's been about 7,000 devices, AC devices primarily installed in Orange County. So, I mean, we're talking about RSAs. I mean, we had one of our industry members mention about that, but with 7,000 installed AC devices within the jurisdiction of Orange County, California, we have not received any placed in service reports from any RSA. So my question to the industry is, to what extent are you guys actually taking ownership and educating your vendors and your RSAs about the requirements of our regulations? So it's pretty, I think throw that out to Keith and Francesca.
Yeah, thanks.
Yeah, great question. And unfortunately, well, we do have an AC product, but as I mentioned before, we are just now starting to look into using it commercially. So we don't have as much experience with that. I can only talk about what we're doing proactively. Keith probably on the same way, is more on the DC side of things. But so when we do use a certified installer, we now are requiring those certified installers to be an RSA and to be fully compliant and up to speed with everything. And so we are working with them to make sure that on both sides we know what's going on. So that's something that I think by coming to this conference, I'll honestly say people at Tesla would probably not have known about this stuff before I started coming here, because we build product and we move very quickly, right? But I think we've learned a lot along the way, and so that's one of the takeaways that we had, was we really got to understand the RSA process with the installer, even though they're doing the certification. When we start doing it on our end, it's going to be the same thing. So we are trying to make sure we're bringing that to the team that we work with. I hope that makes sense.
I'll take that last question from you if you want to.
So speaking to Joe Schmoes / consumer satisfaction or understanding that they're getting what they're paying for, how feasible or practical are incorporating the technologies of the test modules into the vehicles, so when you plug in, they can verify what's advertised to them for the cars? It's too expensive to do that, where it tells you the kilowatt an hour, like have the cars tell you as you plug in?
So Tesla has that. We have everything integrated into the vehicle, right? So if you look at the big vehicle UI, those of you who were in Tacoma, right, you probably saw it when we did some of the testing. You have everything integrated into the vehicle screen. We're able to do that because we have a fully integrated system. When you have a charging station owner operator that's different from the OEM, so the automaker, you might not be able to do that, but the industry is moving in that direction. There are other ways, right? There's a screen on the station. There's in the mobile application, that indication is happening. So for us, for our drivers, we have it in the car, and if you leave, because most customers leave, they don't watch their charge session, or they watch Netflix in their car while they're charging. They get a cup of coffee. You can also see it on your phone application, so it replicates the vehicle UI, and it has the countdown and everything in there. So you are seeing it in two places at least.
Yeah.
I don't think that would be Tesla does that, but I don't think it would be necessarily feasible or practical for all vehicles to do that. That technology is relatively expensive. So to do that for something that is very accurate would cost thousands of dollars. And why would you pay an additional several $1,000s for a vehicle when another vehicle that's equally good and valid and identical is several $1,000s cheaper? The average consumer would go for the cheaper vehicle. Secondly, your car right now, a gas vehicle, doesn't have that verification system. And you as a consumer say, I know the pump is valid, the pump was tested, I know the pump is good. So if the pump tells me it gave me 1 gallon, my car isn't gonna verify that, but I know the pump is good, so I, as a consumer, believe it, and then we have consumer protection. Same concept here with electric vehicles. Your car doesn't need to validate it, and it may be able to on some very tiny level, but that super accurate level of verifying it, I don't think it needs it.
That would be the last thing. I just want to be conscientious of our time. But Tina, you get the last word there.
Just very quickly, I've heard a few references to what the consumer sees, consumer confidence. Tim mentioned a little light going on and off. I just want to clarify that right now the code that's in Handbook 44 does require a customer indication. There are some exceptions for some devices, but that consumer look and feel right now that has that indicator 1 there so that the consumer can see what's going in. As Keith said, what happens to the electrical energy once it gets into the vehicle is another issue. But you mentioned, I see it on the device, I see it on the test standard, and it's going somewhere. So I just wanted to note that.
Thanks. Really want to thank everyone for your participation and engagement in the questions. And I'm sure you have more questions. Want to thank the panel here for participating. Every one of them are on the attendee list with their contact information, and I'm sure they'd be glad to take more questions from you offline if you have them. So one of the big things with this conference is networking and getting to know who you can reach out to sometimes to ask questions. So feel free to reach out to any one of us on this panel with anything else. Thank you for your participation, your time, your questions, and we'll adjourn this session and come back in less than 15 minutes at 11 o'clock to do the final joint committee session for this meeting. Thank you.